Exercise 32. So we're going to begin with setting epsilon greater than 0. Actually, no, that's wrong. So we're going to fix some x in R, and then we're going to let epsilon be greater than 0. Choose x0 less than, let's write it out, x1 the way through xk, which is equal to x, such that the sum from 1 to k of f of xj minus f of xj minus 1 is greater than tf of x minus epsilon over 2. And we can do that because t sub f of x is the supremum over all such sums. And so then there is some n, the natural numbers, such that for all n greater than or equal to n and j between 0 and k, we have f sub n of xj minus f of xj is less than, say, epsilon over 4k. And we can do that because of pointwise convergence. So for n greater than or equal to n, and nope, just that, then we have the following string of inequalities. Let's make this a little bigger, actually. So I guess the final thing is going to look a little weird because these will be all like going to have all this extra like margin space over here, but whatever, you can deal with that. So Fn, nope, that is not right. J equals 1 to k of Fn xj minus Fn xj minus 1 is greater than or equal to the sum j equals 1 to k of f of xj minus f of xj minus 1, this thing in absolute value, minus f of xj minus fn of xj. And then we're also going to subtract, this is a little messy, but trying to conserve screen space. So then we're also going to have this. And so we have this whole thing on the inside, and the reason that this works is basically if you look at this, and if you were to bring the other things over to this side of the equation, then this would be true just by the triangle inequality, because if we want to write the difference between fxj and fxj minus 1, you go fxj to fxn, you go from here to here, then here to here, then here to here, and then here to here. And so you're basically using sort of the triangle. It's not technically what, well, it might be what you'd call a reverse triangle inequality, but it's basically just a variation of the triangle inequality. But whatever you want to call it, it is that. So we got sum from j equals 1 to n. We're going to keep this first thing here. And then we're going to, let's see here, we're going to replace these other things with, well, these are all less than epsilon over 4k, and since we are subtracting them, we have the greater than, so things are going in the correct direction. So we've got this. But then what is this? This is equal to the sum from j equals 1 to k of So here, if we were to just bring these things out front, so here we get like a minus epsilon over 2k, and so we factor that out, k times, then you would get sum of f xj minus, well, you won't factor it out, but you just subtract it. But anyways, this is not what you get. You get this minus 1. There we go. And then this, so this whole thing minus epsilon over 2. But then was this greater than or equal to? We chose this to be greater than this. So let's see here. I guess this is a strict inequality. Whatever. So it's greater than or equal to TFA minus, and then we'd get another epsilon over 2 from here. So this is just minus epsilon. Let's see here. By taking the supremum over all such partitions, we get TFN x, this a should be an x, is greater than or equal to TFX minus epsilon. And this is just because we chose a partition like this up here such that this thing held, and then this sum here, that's exactly the thing that you take the supremum over in our definition of TFN. And so basically you just take the supremum and you get this. Period. So here. So then lim inf as n goes to infinity of TFN a, well, this is certainly greater than the infimum over all n greater than or equal to big N of TFN a, which is greater than or equal to TF, God, why do I keep doing this? TFX minus epsilon. And that's, you're just taking this infimum of these things. Then this holds for all epsilon greater than 0. Come on, don't freeze on me. There we go. And thus, lim inf then goes to infinity TF and x, got it right this time, x is greater than equal to TFX. Then this holds, probably don't have to write all of this stuff out, but I'll do it anyways. But this holds for all, let's see here, for all n, right. No, this holds, oh, I wrote something different down. This holds for all x in R, and hence TF is less than or equal to lim inf as n goes to infinity TFN. And I'll leave it to you to verify by a change of variables that this statement implies this statement. That shouldn't be too difficult, so I'll leave that to you. But after you do that part, you're done.